Hello and welcome to another Solana tutorial. Today we're gonna talk about pNFTs, another NFT standard by Metaplex. Do I put my head on? Nah. And yes, that's the most high resolution background image I could find. Metaplex, do better in your branding. Story time! Once upon a time, there was a marketplace, an NFT marketplace, called, should I name it? Yaw. And said NFT marketplace decided to just not pay royalties to creators. So they ignored the creator array, the entries with the pub keys that are listed as creators that were supposed to get the seller fee basis points in royalties with every market sell. NFT swapping protocols already ignored that before, but that's a whole different story. And because ignoring royalties makes the NFT cheaper and people like cheap NFTs, people were going to that marketplace. And then the dominant marketplace, Magic Eden, was like, well, that's not so great. And so they also dropped royalties. And then NFT collection owners were like, well, that's not so cool. Now we're not getting paid, which again spawned a whole conversation about royalties that I don't want to go into. Long story short, Metaplex came up with a solution to fix that. Programmable NFTs, which basically enforce royalties. At least that's one of their use cases. And I would say it's the main use case because that's essentially the genesis of them. But they are more powerful, they can do more stuff than that. And we want to have a look at that. Today is going to be more of a theory session, like what are pNFTs, how do they work, what accounts are there on chain, and how does it work to do transfers without paying royalties, but marketplaces have to pay royalties. Those are the things that I want to find out today for myself, because I also don't know. Like, I'm using pNFTs since a lot of collections have migrated to the pNFT standard, and I actually don't know much about it. I know they're called programmable NFTs, and it's a Metaplex standard, and they have a bunch more accounts, but that's all I know. So we want to get up to speed on the standards because there are not enough NFT standards out there. Metaplex still being the dominant one, so we do want to focus on that. Because they tie in with the CNFTs and the XNFTs. XNFTs, I think, can be pNFTs. And by those lines on my forehead, you see that I don't actually know. So, here we are, talking about pNFTs. From Metaplex. Let's go. Actually, let's start with a recap. With my favorite illustration, Loris made a great illustration about NFTs. We start with that. Quick little recap. That's a regular NFT on Solana with the Metaplex standard. Each NFT is a token. So with the token program, we have the mint account and the associated token account as you would with a normal token. Then additionally, you have this metadata account that stores all the metadata, has a URI that points somewhere off chain. And then also for actual NFTs, we have a master edition or an edition account that then ensures that there's just one of those tokens. So that's essentially how a regular NFT is represented. Now, with pNFTs, there's more. Programmable NFTs. So version 1.7 of the token metadata introduced a new type of asset class. Oh, the last time I reviewed this, I think was 1.3. We have this new asset class next to the NFTs, fungible. There we have a programmable non-fungible, which is a special NFT that is frozen at all times to enforce custom authorization. There we already learned the first thing. The way that they handle this is by keeping the NFT frozen in the token account. So essentially they always freeze the token account, transfer it there, and then freeze it, thereby guaranteeing that you cannot transfer it without going through their program. And that's a common thing to do, right? If you just freeze it, you still have it in your wallet and you kind of still own it, but then you can't transfer it. Okay, it's important to note that the token standard is set automatically by the token metadata program and cannot be manually updated. If the token has a master edition account, it's a non-fungible. Each of the standards have their own schema. So programmable non-fungible. Similar to the normal NFT, the normal non-fungible, except that the underlying token account is kept frozen at all times to ensure nobody can transfer, lock, or burn programmable NFTs without going through the token metadata program. Yeah, that's what I said. So they ensure that all of the transfers, so essentially everything you do with a token, goes through the token metadata program. so they can apply their rules to, not allow certain transfers or whatever. This enables creators to define custom authorization rules for their NFTs, such as enforcing secondary sales royalties. You can read more about programmable NFTs here. And we go to GitHub. Okay, first check out the metadata field. That's pretty much the exact same as for a normal NFT. Well, GitHub, MPL, token metadata, programmable NFT guide, programmable NFT guide, technical summary. In order to support assets that can have customizable behavior, a new asset class will be introduced. A new asset class was introduced into the token metadatas token standard struct. This will allow for flexible configuration of various lifecycle rules, which will be triggered at specific actions. So, there are some actions, like when it's burnt, when it's created, when it's locked, when it's transferred. This is probably the main one. And at those actions, we can trigger certain whatevers. How do we do that? We'll see. These lifecycle rules will be configured by the creators. And so now all the interactions with those assets go through the token metadata program. And that's important to know because now we're not just working with the token program anymore, which also means that if you want to support pNFTs in your wallet, then you need to specifically support pNFTs. It's not enough to just support the normal token programs. No, you need to specifically also support that. By now, basically all of the wallets already support these standards, at least all of the major wallets and all the major marketplaces. I had a page somewhere once. So by now, all of the major wallets and marketplaces have added pNFT support. So you should be able to use them basically everywhere. Cool, where were we? So whenever you transfer, you need to go through the metadata program instead now. Token metadata will expose new versioned instructions. The addition of authorization rules accounts. And those authorization rules, this account containing the rules, is apparently derived. Or we can get it from the read API that we know from the CNFTs. Okay, extending the token standard. There we go. We get a nice graphic. Perfect. It can have a rule set associated. These rules are then validated at each lifecycle action, and the action is only performed if the validation succeeds. That makes sense. Only if it's authorized, it will actually be performed. Okay. Since these rules are customizable, the tokens have a programmable behavior, and that's where the P comes from in the pNFT. Cool. So this nice diagram highlights those new components. So we have the things that we already know. Essentially, the things we already know are those plus the master edition account here. And essentially, everything in yellow is now changed. Firstly, we freeze the token account, not the token itself. The token can't be frozen, but each token account can be frozen. Usually it's the associated token account that we use. We freeze the ATA and set the delegate to the token record account, which is a PDA with metadata, token metadata, PID, mint, token record, and token. So we can derive this, and it depends on, well, the program ID, obviously, the mint, so which token it is. Token record is just another static thing, and then the token. Hold on, wait, what's the token? Mint, I understand, that's this thing, but what's the token? This one? The token account? I mean, yeah, okay, there's even an arrow here. So that means whenever I change the ATA, so I send it somewhere else, I transfer it, I'll have to make a new token record account. Okay, yeah, and then you just close this when you transfer it out and you open a new one. Okay, sure. So there's this new. In the metadata account, we have a new programmable config, because the metadata account we can derive with just metadata, the token metadata program ID and the mint. So that just depends on the mint. And in there we find the programmable config, which we can also derive with rule set plus creator plus rule set name. Okay, so essentially this can be anything. It doesn't depend on the metadata account. So you can have one rule set for several NFTs. So you just, you as the creator, so you create a rule set. So this, I guess, it just depends on the wallet That's the creator. And then rule set name, you want to be able to have several rule sets. Then you just add another field here so that you can have as many rule sets as you want. But basically that account is then stored in the metadata account. So the rule set account, public key is written into here. And that's 33 bytes more in the metadata account because it's an optional public key. A public key has 32 bytes. And because it's optional, it adds the 1 byte whether or not the programmable config is set. So that's 33 bytes in length for this programmable config. Yes, quite a bloated account here. Yeah, so that then contains the rule set. What else? We have the metadata delegate and the metadata delegate record account. So many goddamn accounts. Remember totally tweeting, oh, why does that need so much compute to mint an NFT? He tweeted that sometime during the MadLats mint. Because I think the MadLats are pNFTs. They are XNFTs, but they're also pNFTs. Pretty sure. So, okay, what is this metadata delegate record account? It's again a PDA with metadata, the program ID, the mint, so far so good. That's the same as with the metadata account. And then it has the metadata delegate role, the update authority, and the delegate. Okay, so the delegate can be any. The update authority is in the metadata account. Okay, so those two make sense. But what is the metadata delegate role? I don't know. Maybe they're different roles. And each role can have a delegate record account. Oh, this is so confusing. It's only confusing as long as you don't understand it yet. We will understand it, don't worry. Oh, my head is again completely in the way of... I'm not a good video maker, am I? Wait. It's very strange to look at me like this. I'm mirrored. At least we have a better view in this now. And the thumbnail as well. So once again, gotta go through this slowly. Regular things that we know. We then additionally have a token record account. That account essentially belongs to or belong is the wrong word. It's associated with the associated token account. So for every token account, we basically have the one record. So this one is in there now. The metadata account we know and love. And it contains a rule set where we specify each rule. And then the delegate record account is a PDA that depends on the update authority, the delegate, whoever that is, and the metadata delegate role that I still need to find out what it is. And in this account, they just store all those things that they made the PDA from. And then that's all that is in this account. And we will understand later why that makes sense, what that's good for. So far, what I understand is there are 3 additional accounts: the token record account, the metadata delegate record account, and the rule set account. And the metadata account is extended for one field, the programmable config that points to this rule set account. And that makes up a pNFT on chain. So we have 1, 2, 3, 4, 5, 6, 7 accounts per NFT now. Oh, great. It's not complicated at all. And then other chains laugh at us for what is that standard? But okay, back to my normal self. Unified instructions. For our pNFTs, we now need to use this new instructions. And they call it unified instructions because those instructions also work for all the other asset classes. So for fungible asset and whatever. But for the other ones, you can also use the ones that you previously used, like for instance, just transferring it with a token program. But this interface also allows for all other asset classes to be used like this. All your fungible assets, fungibles, or normal NFTs can also be used with those instructions from the metadata program. So the token metadata now includes all of that, so much that it doesn't even fit on one page. Burn, create, delegate, migrate, lock, mint, print, revoke, transfer, unlock, update, use, verify. So all of those now need to go through the Metaplex program, especially the mint and the transfer are probably interesting for us. And each of those instructions will use versioned arguments, structs to facilitate future updates. Aha, so those arguments that we put in there, they are versioned, and therefore we don't need to update our instructions, just the arguments that those instructions take. That's actually a nice setup. So if I in a future version want an additional field in the transfer arguments, I just change the transfer arguments and not have to change the entire instruction. And here's again a list. The burn supports burning programmable, non-fungible, non-fungible additions, and fungibles. Create, delegate, and we see some things are not implemented yet or not available. Migrate might be interesting from non-fungibles to programmable non-fungibles. So that's how we make a pNFT out of a normal NFT. We use the migrate instruction. Might be interesting to you if you want to update your collection to pNFT standard. With mint, you can not only mint pNFTs, but also NFTs, and so on and so on. Yes, yes, yes. So transfer, wallet to wallet transfers, wallet to program transfers, program to wallet transfers, and program to program transfers. There they make the distinction because once you have to sign with a signer and once you have to sign with a PDA, so with seeds, that's why it has to be handled differently. Again, update, you can change the metadata for all of them. Actually, scrolling through docs is kind of boring, isn't it? Kind of want to just use this stuff, right? I just want to mint myself an NFT now. Holy shit, there is a lot of theory to go through. Before we actually go through some code, let's talk about those delegates. There are two types of delegates on the token metadata. Token delegate and metadata delegate. So we have the token delegate, I think that's this one. And then we have the metadata delegate. Token delegate. That's the delegates that operate at the token level. So the SPL token. So we can perform actions on the token account. Who would have thought? Burn, transfer, freeze, etc. There can only be one token delegate at a time, and they do not have an individual delegate account associated. This information is stored in a token record account, which holds the information about a particular token account. I mean, so far we followed that. Each token account has one token record that stores the delegate and is derived with those seeds. Metadata, program ID, mint ID, token record, token account ID. There it says it specifically, it's the token account. This token record now contains key, whatever that is, the bump, the state, the token state, rule set revision, the delegate, and the delegate role. So what is a delegate role? Oh, I need more info on that. So token state, 3 different values. Instructions are restricted depending on the token state value. So token state. Okay, cool. So that's that. There we have unlocked, locked, or listed. That record that corresponds to the token account, the token record, has a state that can either be unlocked, locked, or listed. Okay. If it's unlocked, then the owner can transfer it and burn it and revoke it. If it's locked, then they can't do any of that. They can only delegate the unlock. Only the delegate can unlock. Yeah, so the owner can't do anything, but the delegate can. The delegate is also stored in there. And if the state is listed, then the delegate can perform a sale, but not a transfer. Only an actual sale, which is different to the transfer, enforcing the royalties and stuff. And if it's unlocked, we can sell or transfer. Token delegate role, so that's this one now. A token delegate role represents the different delegate types. There are 6 different types. My brain will explode soon. I warned you, a lot of theory today. So for this token delegate role, we have 6 different values, and then instructions are restricted based on those roles. So we already saw 2, sale and transfer. Wait, so the role, this now corresponds to the token account, right? So every time it's moved somewhere else, it can have a different role. So they apparently can only be used in combination with a certain state. So sale can only happen when listed, transfer only when unlocked, lock transfer when it's locked or unlocked, utility also locked or unlocked, staking, yes. Okay, and that's the transitions. If we have a transfer role, then the owner does the transfer, then the role becomes none. If a delegate transfer happens with a sale, that works, and again we result in none. Oh, my head already hurts. This is a bit much. Moving on to metadata delegate. So that is then this part, the metadata delegate record, which depends again on the mint delegate role, the update authority and the delegate. Yes, program ID, mint, delegate role, update authority, and delegate ID. Those are delegates that operate on the metadata level. So not on the token level, but on the metadata level. Do not have an associated SPL token delegate. There can be multiple instances of the same delegate. Yes, because the delegate is just one part. You can have a delegate with the one role and a delegate with another role makes another PDA. Currently, there are 3 types of metadata delegates. Okay, now it gets interesting again. The collection, update, and use. Can set and verify NFTs to a collection. If that guy has a collection delegate role, then this guy is allowed to change this thing. But there's also still the update authority, but maybe the update authority is now set to, maybe you need the update authority and this delegate record, or you need to, this is so complicated. If the type is update, it can perform updates on the metadata account. Well, I mean, like changing the URI. That's interesting. So you split the authorities for changing the... That is cool, because before, when you had just one authority, this one update authority, then the NFT collection owner needs to fully trust their dev that they don't mess with their royalties, right? Because if you have the update authority, because you need to make changes to the NFT, then you could also just change the creators. But since those are now split, you can just give the update delegate to your dev, and they can then change the URI and the name and the symbol, but they cannot just change the creators to receive royalties. Collection, not creator. I messed that up. Sorry. So maybe the creators are still in the same update. Okay, fair enough. So it doesn't prevent that. And then the use allows the actor to use the asset and decrement the uses. Yeah, that's a whole different topic. And then a nice table that I actually understand. The delegate collection can change the collection, but not use and update. The use can use, but not collection and update. And the update can update, but not use or change the collection. Let's talk about token authorization rules. I guess that's that part up here. Oh, there will be a separate program, the token authorization rules program, that provides the ability to create and execute rules and restrict the token operations discussed above. So we have yet another program, additional to the token metadata program, that just handles those rules. Authorization rules are variants of a rule, and they implement a validate function. There are primitive rules and composed rules, where composed rules are just a combination of more primitive rules. Store any accounts or data needed for evaluation, and at runtime will produce a true or false output based on the accounts and the well-defined payload that is passed into the validate. So essentially, what you're telling me here, this is an instruction that is executed, because the instruction gets the accounts and some data, and then the instruction is executed and returns true or false. Pretty simple. And then let me guess, the composed rules is an AND combination of all the primitive rules. So it's again true or false based on whether any or all of the primitive rules return true. So we can have an OR and an AND. So we can have AND or. Do you get what I'm saying? You get what I'm saying? Of course you get what I'm saying. It's super simple, right? Composed rules can then become combined into higher level composed rules. So you can stack that, right? You have a composed rule made up of composed rules, and those rules can implement more complex Boolean logic. Yes. Because of the recursive definition of rule. So a rule is a primitive or a composed, which can be composed of several rules, which again can be composed rules. Calling validate on the top level of a composed rule, we start at the top and validate every level. Yeah, I mean, that kind of makes sense. And more details can be found here. Well, let's go there then. Because we didn't do enough theory yet. The MPL token auth rules program. Great. Examples. Find a rule set. So here it creates the PDA, or it finds the PDA for this creator of the rule, and then any name. So remember, it's rule set creator and rule set name. I'm assuming all that find rule set address does is add the first key and then does a find program address on it. We create a rule set. The same also in JavaScript. It's a bit easier to read for me. Wow, this is all very complicated. Hex buffer. There he builds the rule type. Okay, so essentially a rule is just serialized like this with a rule type, the length. Why this length? Or are those individual bytes? 18 hex, its 0 is 128. That probably makes sense because we have 32 plus 32 plus 32 plus 32, so 4 times 32, which is also 128. Okay, that makes sense. This length does not include the first two, so the type and the length. It just includes the length of this part, and this part is 4 times 32 bytes in this case. Essentially what I'm saying is all of the rules that are in here, I guess, are just serialized in there, you know? It's just a rule, and the rule itself is serialized. You get a type for the rule, like which sort of rule is this? Like a must match all those public keys or must match one of those public keys, and then all the public keys. So that only those 4 or 3 public keys, and that's the easy way to build it. So the test made it manually, and the easy way. So we were looking how that looks behind the scenes, which is always cool to learn how it actually works. So we have a public key match, that's the type for this rule, and the field is my account. So yeah, all a bit complicated, and so far we really just clicked through some docs. Like, what rules are there even? Can result in success, failure, or an error. And both failure and error will return false for allowing the execution. So, and there we have the and or to make composed rules. All of those rules need to pass, or any of those rules need to pass. We can even do a negation. This rule must not pass. And then we can compose, right? Then we can have all including one, which is a not that contains another rule, right? Because it's recursive. And then the actual primitive rules, I think those are those now. Yes, we have to go through source code because I don't find any good documentation anywhere. I mean, at least there are some comments in here, so that's good. In addition, a signer must be present. So we provide an account, and that account needs to be a signer. Cool, I understand this one. Next, pub key match. Direct comparison between pub keys. Compare some pub key from the accounts with a pub key that we write into the payload, I guess. And then we can do pub key list. Pub key must be in the list of pub keys. So it's not one pub key, but it can be a list of pub key and needs to be one of them. Couldn't we just have the normal NFTs and everybody just stick to paying royalties? No, we cannot. Oh, pub key tree match, even better. The pub key must be a member of the Merkle tree in the rule. Oh, great. So now we just provide the Merkle tree root and a Merkle proof. Yeah, because that makes sense, because if you have a lot of pub keys that you want to match, then you just want to store the root and work with Merkle trees. We have had a look at Merkle trees. If you don't know what that is, there's a video on that. Then PDA match. Wow, there are a lot of rules. Program owned. Pub key must be owned by a given program. Okay, that, I mean, makes sense. And then the same with owned list, where we have several programs. And then the same with the tree. Any of those, but now in a Merkle tree. Then amount. Comparison against the amount of tokens being transferred using the comparison operator. So the amount that is being transferred must be then this amount. We have either less, lesser equal, equal, greater than. Those are the comparisons. So we could do an equal amount must be equal to this amount that we specify. We could do that. For NFTs, that doesn't really make much sense, but for other token transfers, it does. Comparison based on time between operations. Currently not implemented. This rule is planned. Okay. Move on. Is wallet. Aha, this is interesting. The true test if a pub key can be signed from a client and therefore is a true wallet account. The details of this rule are as follows. A wallet is defined as being both owned by the system program, yes, okay, and the address is on Curve, yes. So there is a private key for it and it's owned by the system program. So it hasn't been assigned to any other program. Then it is a wallet. Oh, that's a simple one. It's just a pass. It will just always succeed. Nice. A tautology. And we can build a always fail by doing not pass, combining it with this one. Not, and then in here, pass, broken forever. Okay, 2 more. Program owned set. Must be owned by a program in the set of pub keys. Okay, it's pretty much like the list, but now we have a set and not a vector. Okay, fair enough. Don't know what that is, but let's ignore it. Can't be so important, right? Okay, and then we have the actual implementation. Validate takes the accounts and the payload, matches the result. And that's what I said earlier. If we have success, we say okay. And if we have failure or error, we say error. So this low-level validate will give me a rule result of either success, failure, or error. And there are the implementations for all those rules, which I'm not gonna go through now, but you can look at that source code. I just want to see the pass because that's the simple one. Validating pass. Just success. All right, we even looked into the source code of this to understand what rules we can make. The most important ones is we can match pub keys, one or several. We can match programs, like the program must own it, and we can check the amounts that are being transferred. And then we can make combinations of all those rules, and that is a rule. Those are the rules. And then the rule set is created from a rule. The rule set then has the owner, the version of the rule set. We also store the rule set name. It's just used in PDA derivation. And then it contains the hash map of rules. Ah, interesting. So for each operation, it has a rule. So the rule set for each of those, for each of the operations, it will give me the rule. And I think that's what we saw there. I think those are the ones. Like burn, create, delegate, lock, mint, transfer. So if, for instance, for the transfer, we can define a rule. For the mint, we can define another one. And all of that together goes in this hash map. For transfer, we have this rule. And the rule, again, can be a composed rule that consists of several rules. And then for mint, we have a different rule. And for update, we have a different rule, and so on. Lots of theory, lots of theory. Did we make progress understanding this? Somewhat. We now know what's stored in there. Oh, there's already a v2 of this. So they changed from the hash map to a vector, which makes more sense. Oh, which makes sense because it's more efficient to store it like that, because we are writing it into accounts. So we just have the list of operations and then the vector of rules correspond to those. Right, so if we have in the operations first transfer, then the first one in the rules will be the rule for the transfer operation. I guess that's how this works. Yeah, so there's a second version that I now also looked at, okay, but it's pretty much the same. Oh, my head still hurts from all that knowledge. Ugh. But I didn't get much smarter in terms of why. Okay, wait, I can imagine stuff now. Hold on. I still didn't really find out why I can do a normal transfer on pNFTs, like wallet to wallet, but royalties are still enforced. But I guess it comes down to this is wallet constraint. Payload get pub key field to string. Then we check that it's the system program, and then it's not implemented yet. But we get an error. So I mean, this shouldn't even work yet. So we can't have a rule if it's wallet. I mean, if we had that, then we can say, yeah, if it's a normal wallet, you can transfer, but we don't allow transfer from PDAs because as soon as we interact with the program, so any sort of marketplace or swap would have to put it in a PDA. First of all, I still don't get how they enforce royalties and still allow normal transfer. And secondly, there's still a way to circumvent that, isn't there? I just have to sign myself and send it directly. It just can't be in a PDA. or a system program account that is owned by a PDA or owned by a program. Programmable config. There is a programmable config. Does that exist actually? Because there are probably like default rules. I mean, I can have a look at a pNFT. I own one. Let's see what we can see here. Because this is a pNFT. The metadata should have a pointer to the programmable config, but it doesn't show that here. Also doesn't show here. But then there was a normal transfer that I did from wallet to wallet, and that should already be with the pNFT. Metaplex token metadata transfer. See, that's with the Metaplex program. Thor account transfer freeze account. Authorization rules program. There we have the auth rule, and there we have the authorization rules. So there we have the account, okay, that contains the rules. Rules account. So this, some of it is actually plain text. Metaplex foundation rule set. So that kind of lets me guess that there is a standard Metaplex rule set that every or several pNFTs just use. Because what is in there? The rule set has a header, an owner, and then a rule set name. So header, yeah, that would make sense that this is the name, Metaplex foundation rule set. Then there comes operations, and the operations are transfer. I think there's just transfer. All must be given. The amount must be equal to something. So there's an amount equal rule. Any of the program owned list. So essentially the rule is just made up of a lot of serialized data, and it's literal text that is being serialized in there. It's literal words: is wallet, destination, EQ, amount. That's the actual words in UTF-8 is encoded in there. There are no enums of values, that it's actual text matching. Blah, 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 bloop. So actually, I would be interested if so transfer, pass, delegate, pass, staking, pass. Oh, wait. Or maybe that's still a V1. Maybe that's not a V2, but a V1, and it has the hash set. So the transfer has those rules. The wallet to wallet has those rules. Sale delegate just has a namespace. Transfer delegate has a namespace. Program owned list. Maybe they're listing the actual programs in there, like the marketplaces that are allowed to move the NFT. But then the other, transfer wallet to wallet, gives you a pass. Transfer owner gives you a pass. But yeah, so let's check if my assumption is somewhat correct. How did I even get there? By a transfer. Okay, so I also transferred my MadLad once. So was transferred from here to here. We have the authorization rules, EBJ. That's the same one, right? Yeah. So apparently all the pNFTs use the same authorization rules, which is this one account apparently by Metaplex Foundation that provides the rules. So all of that complicated stuff, they are just setting to a given rule set, and they don't build their own rules, which you can do. I mean, since the one use case of pNFTs is to avoid royalty fraud, it makes sense to only have this one rule set, define it once, and then keep that for all the collections. You can program it the way you want to by defining a different rule set, but it looks like all of the collections use the same one. Okay, and here you store, wait, I'm starting to get this, hold on. Here you store the revision, which is 9 bytes, so it's because an optional 8 bytes. Which of the revision in the rule set we are using? Because, you know, they could change. If this account changes, then, you know, it might get blocked or locked in some way because it thinks it still has other rules than it actually has. That's why there are revisions like that, where you have several revisions, and the token record account remembers which revision we're working on. Maybe that's also what we see in here with the Metaplex Foundation rule set. So that's the first revision until here. And then we have a second revision from here, or like somewhere here, I don't know where it starts, with again a bunch of that stuff. Oh, and maybe there's a third revision there again, Metaplex Foundation rule set, third revision. But that all just has pass. I don't know. Still gotta learn a bit about this, but it's starting to make more and more sense. The more I look at it, the more sense it makes. I still think this is an optional thing. If you don't want to delegate, could still just live with those accounts. Just another one per NFT that changes whenever it's transferred. And this one, that's just one account for the entire collection, or even the entirety of Metaplex pNFTs right now. Just the one account with the revisions. And we could double check that. That would actually be interesting, because we know what it is. So my assumption would be that this guy who signed this, the ELS. So just real quick, as a last order of business, can I, if I put the seeds rule set, then this guy as the creator, and then name probably Metaplex Foundation rule set. I would assume if I derive a PDA with those, that I then get this EB. That is my assumption. I will check this right after a short break. Create address with seed. Generate a derived account address with a seed. Well, I mean, that sounds like what I want. Flex options, seed and program ID. Uh-oh. Well, then it's too complicated of a seed to derive this. Are you sure? Can I not have like multiple seeds? So this is just for like simple stuff. I mean, nice try, Solana CLI, but it's just, you know, I mean, now I need to make my own script anyway, because you don't allow for more seeds. And that would be so easy to support. Maybe I make a pull request about it. Anyway, so we make ourselves a nice little program. So we start with rule underline set, rule set, the creator. So I'm gonna make a creator to buffer or to bytes, whatever. Then rule set name, and there I assume that's the rule set name. And then I find program address, which gives me a PDA and a bump, and I'm just interested in the PDA. Let's see. I would expect EQ something. EB, yeah! EBJL. EBJL. So, all my assumptions are correct on this one. This is, in fact, this rule set account that apparently Metaplex created. And then all the, or at least the two collections that I checked, Quicknode and Madlets, both use this rule set for their pNFTs. So probably several collections just use the same rule set, which makes sense. I mean, most of them just need the same rules, which are enforce royalties. Programmable NFTs support both allow list and deny list based approaches. Yeah, because we can have a not. The Metaplex Foundation will provide an optional rule set based on allow list that will be updated periodically to only include programs that pay creator royalties for convenience. Interesting. It's starting to make sense. So Metaplex, probably in this account that we derived here, this one, the EBJ, will essentially make an allow list of all the programs that are allowed to transfer the pNFTs. That makes sense now. That makes sense. So the rules don't actually contain the amount, like making sure that the amount in royalties is paid. No, they make sure that only programs paying royalties are allowed to move the NFT. That makes sense. Okay, that's an important realization that I just had. Okay, so essentially Metaplex has this allow list with all the programs that pay royalties, and you could make your own one and then basically say only Tensor is allowed to move my NFTs, or only my program is allowed to move the NFTs or something like that. But there is the one by the Metaplex Foundation that has this rule set for our convenience. Okay, let's create a programmer NFT. Let's go. And I'm just going to copy the code without thinking much. Should we once again just use the same link? Since they provide the tutorial, might as well make some advertisement for Quicknode. I just want to quickly get a pNFT minted. Okay, and now the important part, function to mint. I'll of course link that tutorial down below. Inside here, we do a transaction builder from the Metaplex SDK NFTs builders create. And here important, the token standard programmable, non-fungible. That's the only really important part here. The rest is the same as with a usual NFT. And then we just call it. Easy as that. So, minting pNFT. Success. Wow. Wow. First try. This is the NFT we minted. And its first pNFT with that art. Yes, okay, that's fine. Let's check the transaction here. More expensive than a regular NFT because we have more accounts to pay for. So we have the mint, I think that is. That's the token mint. That's probably the token account. No, wait. This is the token account. I know it from those numbers. This is the token account. Then this is the metadata account. This is most likely the edition. And this is then, I'm assuming, the token record account. And just to prove that that is actually the token record account, let's also derive this just for fun. Of course, from the token metadata program. That's the program ID. The seeds were metadata, token metadata program ID mint. So those are mint, token record, and token. So the ATA. I could also derive the ATA, but if we go to distribution, this is the owner, this is the address, token record, and then the ATA. Yep, that's the ATA. Cool. It's nice to have an understanding of those things. It's really cool. And I speak really quietly because it's late. But I want to get to the bottom of this. So we have mint, ATA, and my assumption was this one, the 82EE. That's what I would expect for the token record account. So let's check if I find PDA 82EE. Nice. Nice. This is actually what's happening here. Amazing. I like it. Okay. So we minted a pNFT. We now hold a pNFT in our wallet. And I think I want to end it here to leave it as a bit of a cliffhanger. Because we can't transfer this. I will showcase. Hold on. Import my wallet. It's okay if you see this. Here I have this and this first pNFT. And I can send it. This will work because Solflare implements the correct transfer, the one from the token metadata program. So we will see that this is a Metaplex token metadata transfer instruction. And let's check actually which rule set was used here. Authorization rules Metaplex token metadata. Authorization rules is also the program itself. Maybe because we did not provide any rules and then it sets that. Rule set null. Aha. So I didn't provide a rule set. If I want to provide a rule set, what type is this? A public key. Then I could be like public key and also provide this default rule set here. Then it should mint one with this rule set. There, we have another one now. This one should now have the rule set set. The rule set set. And we see authorization rules is now the EBJL. Nice. Cool. So once I send this to a program that is not on the allow list, then, well, it stays there forever. But that's a topic for another video. I think we understand pNFTs quite okay by now. At least I do. At least I have made myself a mental model today of how they work. I mean, it took me a while if you look at all my tabs. To recap, we essentially add an entry in the metadata account that points to a rule set that in most cases is given by Metaplex, the default rule set that contains all the marketplaces, or actually the programs of marketplaces that enforce royalties and therefore are allow listed, and also allows for wallet to wallet transfers, but blocks every other transfer from a PDA, from or even to a PDA. And then this token record account is created for each token account that we create. Actually, we should see this when we transfer, that one of them is, yeah, exactly. So here we see that the ATA as well as this token record are both removed, and therefore a new token record and a new ATA are created. So just minus minus plus plus. And this token record account essentially just makes sure that the right revision of the rule set is taken into account. And it also tracks the state of this token. So is it listed? Is it locked? Or is it free, unlocked? We can have more delegates for the metadata, but we did not look at this in practice today, and that is also not required, as we found out, because my NFT does not have this one. And yeah, every token account is always frozen, and that makes sure that only the token metadata program can actually unfreeze, transfer, and then freeze again the token accounts, and thereby making sure that the token cannot just be transferred the normal way, basically adding functionality on top of the standard token program, essentially crippling the token program to, no, you're not allowed to do anything anymore. Only if I say so. So we always need to go through the token metadata program now if we want to transfer or do anything with the token. Yeah, and that is that. That's a pNFT. And I think that's enough for today. I think that is good enough. We've learned a lot, and we've learned enough about the Metaplex pNFT standard. Don't you worry, I will make more videos on that where we actually try this stuff out, like sending it to a program and then not being able to retrieve it anymore, and maybe building our own allow list to also get an understanding of that works. Let me know in the comments if that is something that you're actually interested in, or if you're not interested in pNFTs anyway, or you're happy with just the standard allow list stuff that Metaplex provides. Because let's be honest, for most use cases, when you just want to enforce royalties, you might want to use their rule set. But hey, if you want to do more complicated stuff, maybe you want to build your own rule set. You can build an NFT that only your program is able to transfer. If you're interested in that sort of use case, let me know and we'll have a look at it. You can also let me know on Twitter, by the way. Follow me on Twitter while you're there. And then subscribe here on YouTube, like this video, and watch the other ones that I also made already. I want to be the go-to guy to talk about NFTs on Solana. I want to know it all, I want to understand it all, and I want to be able to teach it. And yeah, I hope that you have fun joining me on this journey, learning about Solana NFTs. In this episode, pNFTs. Always sounds weird if I pronounce that. pNFTs. I don't know, toilet talk-ish. So that's that, and I will see you in the next video. Until then, bye-bye.